Use the definition of speed v, frequency f, and wavelength lambda to derive the wave equation. You know that the speed of wave, or speed in general, equal distance over time. Distance traveled per time. Now, if this distance traveled is the wavelength, so the time needed is the time period. So we can write v equal distance over time. Distance here is the wavelength and time is the time period. We already know that the time period equals, substitute t with 1 over equal lambda over 1 over f. So it becomes lambda. A source of sound of frequency 236 is traveling at constant velocity 20 meters per second. A station observer has a microphone connected to a cathode ray oscilloscope. CRO, the microphone detects the sound waves as the source moves directly towards the observer. The resulting trace on the CRO is shown in figure 5.1. The time phase on the CRO is set 1.0 millisecond per division. Millisecond per division. Type. Let's see here, we need to calculate the frequency of the sound wave. Type. Let's find the time period here. Let's see a whole wave. How many squares for a whole wave? Let's start the wave from here. So the wave ends here. So we'll have 1, 2, 3, 4 squares. 4 squares. Or you can take from crest to crest. Also you have 4 squares. 1, 2, 3, 4 squares. Here is the square, 1 division. Okay. So let's write t equals 4 times the time phase. Here 1 millisecond per division. So 1 milli 2 times 10 power negative 3 equal 4 times 10 power negative 3 seconds. Now we need to calculate the frequency. Frequency equals 1 over t equals 1 over 4 times 10 power negative 3, which equals 250 hertz. So the final answer 250 hertz. Determine the speed of sound in air. 236, this is the frequency of the source, and speed is 20 meters per second. So the frequency is increases from 236 to 250, which means the source sound is moving towards the observer. So write the equation of Doppler effect. O equals Fs V over F minus Vs. Minus here because the sound is moving towards. Okay, but this equation does not give us the speed of sound, so we need to arrange this equation. So let's try it here. Write the equation first. Fo equals Fsv divided by V minus Vs. Cross multiplication. Fo times V minus Vs equals Fsv. Fov minus Vfsv equals Fo times Vs on the other side. We'll take V here as common factor. V, so V equals FOVS divided by FO minus Fs. So write this equation here. V, okay, for FO of the frequency of observed So it equal to 150 vs 20. The speed of the source 20 meter per second. F is the frequency of the source 250, and F naught O is the frequency observed by the observer 236, gives you 357.14. We are lucky 160. Anachrome wire X of length 45 centimeters and the cross-section area 4.7 times 10 power negative 7 meters square is connected into the circuit shown in figure 6.1. The resistance of X is 1.1 ohm. The cell has electromotive force EMF 1.3 volts and calculate the current. The current is, we use the equation of current. I equals V over R. V is 1.3 divided by R is 1.1 ampere. 1. The number density of the charge carrier's electrons in the nichrome is 8.5 times 10 power 28 per meter cube. Calculate the average drift speed of the charge carriers in X. Here is the equation. V, the average drift speed, equals I over NA cube. For the current, 1.18 as we calculated here. N number density, as it here 8.5 times 10 power 28. And for A cross-section area, we have it here 4.7 times 10 power negative 7, and Q is the elementary charge or the charge of electron 1.6 times 10 power negative 19 equals 1.846 times 10 power negative 4 meter per second. We just have the final answer here becomes 1.8 times 10 power negative 4. Calculate the resistivity of the nichrome. We know that resistivity, the equation of resistivity, rho equals R A over L. We have it here 1.1. A cross-section area, we already have it here also as we used before. And L, the length of the wire, is mentioned also here. 45 centimeter, which is 0.45, 1.14888 times 10 power negative 6 ohm meter. So final answer will be 1.1 times 10 power negative 6. Wire Y is identical to wire X. Wire Y is added to the circuit in parallel with wire X as shown in figure. We have just two wires X and Y. State and explain the effect, if any, of this change on the reading on the emitter. Let's see. Adding another wire in parallel will cause the total resistance to decreases to its half because they have the same resistance. Two resistors in parallel, total resistance decreases. Of course, the current increases, so the reading on the emitter increases too. What's the effect on the average drift speed of the charge carriers? The total current increases as we concluded here, but this is the main current, and in the wire X and Y the current divided equally between them. So the same current before adding Y, but it will be divided between X and Y unequal. Why it is unequal? Because they have the same resistance. So the current in X still the same. So the average drift speed does not change. Okay, let's move to the next. Nitrogen 12 N712 is an unstable isotope of nitrogen that decays by the emission of radiation to carbon-12. Complete the full nuclear equation for the decay including all particles involved. Nitrogen decays to carbon, so let's write the carbon notation. C612. What happening here? 7 decreases to 6, which means emission of beta positive. Emission of beta positive. So write the notation of beta positive, 0 for the mass of the nuclear number and positive 1 for the charge. Positive 1 plus neutrino V00. Nuclear number 0 and proton number also 0. B. Hydrogen 1 is an isotope of hydrogen. An atom of hydrogen 1 comprises a proton with an orbiting electron. If we draw it, we have a proton and electron orbiting the proton. An antiparticle equivalent of hydrogen 1 comprises an antiproton. So here is positive proton, we have negative proton or antiproton with an orbiting positron. Okay, the positron orbiting the proton. So this is the antiparticle of hydrogen 1. The antiquark in the antiproton are antiparticles of the quark in a proton. State the charge of the positron in terms of the elementary charge E. This is the positron, this is positive, so the charge here is positive. State the group or class of fundamental particle to which positron belong. Positron belongs to electrons, which is light. Particles belongs to the leptons. In table 7.1, state the flavor and the charge of the 3 antiquarks that comprise an antiproton. Let's check first what is the proton. The proton is made up of a proton made up of up quark, another up quark, and down quark, made up of U, D. The charges of them: for the up quark, the charge is positive 2/3. Another up quark, positive 2/3. And for the down quark is negative 1/3. The overall equals positive 1, which is charge of proton. Antiproton, it made up of the antiquarks, anti-up, another anti-up, and anti-down. So it made up of U dash, and D dash. What is the charge? Is the opposite of this charge. So for anti-up, the sum of them is negative 1, which is the charge of the antiproton. Okay, so now we can write the flavors here and the charge. Flavors will be the same: anti-up, another anti-up, and anti-down. For the charge, anti-up, negative 2/3. For anti-up, negative 2/3. And for the anti-down, positive 1/3. The overall of them is negative 1. This is the last question. Thank you. See you in other videos.